Example 13, you've got 3 points which lie on the circle, and they're shown in the diagram here. You've got to show that AB is a diameter of the circle. So you've got to show that AB goes through the centre. So how are we going to do that? Well, my circle theorems tell me that if that is the diameter of a circle, then the angle in a semicircle is 90. So that should be 90. Now, how can I prove that that's 90? Because if that's 90, then the green line is indeed a diameter of the circle. So the way to prove that that's 90, I guess, is to prove that Pythagoras' theorem works for that triangle. So I'm going to need to find each of the side lengths and then show that the hypotenuse is the sum of the squares of the other two sides. Right, here we go. So I've got to find the distance from A to B. Right, so that's going to be the square root of A and B. The difference in the x-coordinates is 12, and the difference in the y-coordinates is 4. So AB is the square root of 144 plus 16, which is 160. Okay, right, what about A to C? AC. Right, here's A, and here's C. Okay, so the distance from A to C is the difference in the x-coordinates, which is 4 squared and 8 squared. 4 squared is 16 and 64 is 70, so that's root 80. Okay, and now I also need to find, I've done AB, I've done AC, so I need to find CB. Okay, so CB. CB is going to be the square root of, right, here's B and here's C. So I've got 4 to minus 4 on the x, so that's 8 squared. 5 to 9 is 4 squared. So that gives me the square root of 64 plus, well, that's the square root of 80. Again, isn't it? So now I need to show that Pythagoras works for this. So I need to take AB squared and confirm that that equals AC squared plus CB squared, because if it does, then Pythagoras' theorem holds true. So AB squared is 160, and AC squared is 80, and CB squared is 80. So yes, Pythagoras' theorem holds. So AB, sorry, not ABC at all, but angle ACB equals 90 implies AB equals a diameter. Good. That's part A done. Right, so AB is the diameter. Now I've got to find the equation of the circle. Now to find the equation of the circle, I need the centre of the circle and the radius of the circle. How to find the centre of the circle? Well, if AB is the diameter, then the centre of the circle is the midpoint of AB. And the radius of the circle is half of AB, isn't it? Right, so let's do this over here. So the centre of the circle C, well, I won't call it C because I've got the point C already. So the centre is the average of the x-coordinates of A and B. So that's minus 8 plus 4, so it's minus 4 over 2, and then I've got 5 and 1, 6 over 2. So the centre of the circle is at minus 2, 3. And the radius of the circle, to find the radius of the circle, I'm going to be looking at the centre, which is minus 2, 3. And I'll look at point B as well, which is the point 4, 5. Let's have a look at the distance for those. So the radius is going to be the square root of the difference in the x-coordinates, 6 squared plus 2 squared, which is the square root of 40. So the radius is the square root of 40. Okay, so that means that now I can write down the equation of the circle, because I can go x minus a squared plus y minus b squared, where ab is the centre, equals r squared. So the centre is minus 2, 3, so it's me x plus 2 squared plus y minus 3 squared equals the square root of 40 squared, which is 40. So there is the equation of the circle, and that's example 13 finished.